We are going to start Unit 2. So in our math journals, we have some things already in there. Our last one was page 10, which was the integers quiz, slide 24. We are going to skip page 11. You can write on there skip if you'd like to. And let's go to page 12, and we're going to make a pocket. So remember how to make a pocket? So this is where the pocket's going to go. So we are going to go to the next page, fold down the corner, crease it, and only put glue here and here. And then we'll flip it over. So if you need to see that again, this is page 12. On what would be 13, but we're not going to label it because we're going to use it for the pocket page. We're going to crease that down, put glue, and then fold it over. Don't put too much glue. Fold this over. And so now your page 12 should look like this. Page 13 is going to be your Unit 2 divider. So go ahead and fold your divider. If you're not in class for whatever reason, you can get the divider later and put it in on this next page. So remember, it's sandwiched. Don't put too much glue on here because on the back side is some vocabulary that you're going to have to do. And so you don't want tons of glue because then it's a soggy page. And it's not fun or easy to write on a soggy page. Make sure it's sticking out a little bit. And so this is page 14. Okay, we are going to open up our Unit 2 Digital Interactive Notebook now. It is on Google Classroom under Unit 2 Materials. Here is Unit 2 Materials. And it says it's due October 6th. That's just an estimated time that we'll be finished with Unit 2. It could be earlier. I just put an estimate on there. Because your digital interactive notebook is due the day of the Unit 2 test. So since we have some people in and out of class, you can choose to do all your stuff on your digital interactive notebook or do it on your composition notebook. Now, if you're home, it's hard to do it on your composition notebook whenever you don't have the papers that I'm printing out for you. So I would suggest doing all of your notes on the digital interactive notebook.
On our digital interactive notebook, it says that we can only view it and that we can't edit it. Yeah, we'll only do it.
Okay, I will change that right now.
Okay.
Okay, so open up your Unit 2 DIMB. And you can change the layout of your cover of your digital interactive notebook. Go to Layout, and then you can pick one of these. Add your name. Okay, so your slide 1 should be done. Slide 2 is just a problem-solving strategy. Circle the numbers, underline the question, box keywords, eliminate extra information, and evaluate what steps to take, and then solve and check. Slide 3 is our reference materials, and then slide 4 is a general table of contents. We're going to do expressions, multi-step equations, literal equations, inequalities, and words in algebra. So our first section would be Unit 2, 2.1 expressions. And so we have this, which is also the same as your composition book, your unit divider. So what you're going to use is this Quizlet and learn the vocabulary and then write the words on your Unit 2 vocabulary. If we look at the back side of our Unit 1 digital interactive notebook, this is the same thing as that slide. So you're going to write the words in here. So go to the Quizlet, learn the words, and then write them on your composition book. Okay, you can choose to do the online interactive notebook or the paper interactive notebook. If you are in class, I will give you the papers. If you want to do both online and the composition book one, you can do that. So this is what we should have. So if I zoom in, so I'm going to go through it pretty fast. Simplifying the expression, reciprocal, inverse operations, less than, greater than or equal to, variable, coefficient, equation, greater than, inequality, less than or equal to, constant term, and expression. So let's go to slide 7. So I've created a little foldable booklet for slides 7, 8, and 9. So I'm going to do mine on paper. You can do it on the digital interactive notebook if you'd like. But since you are in class, go ahead and do it on the paper. If you're not in class, you can do it digitally. So this is going to go here, which is page 15. And we're going to label this expressions. So we're doing a quick review over what an expression is and also how to simplify expressions. You don't have to glue this in just yet. I would glue it in after we fill it out. So in our in our digital journal, we actually have the ability to drag and drop these. So let's look at the first definition. An algebraic expression written with numbers, letters, or both. That would be a term. And the example for that would be 5, comma, or x, or 6b, or 7x squared y cubed. Those are examples of what a term is. So a term has numbers, letters, or both. Remember, the letters represent some number, so they're variables. The number in front of the variable is called your coefficient. So let's say we have 5x, 7y, 2/3 wz, and also abc. Let's write what the coefficients are. Coefficients are the numbers that are being multiplied by the variable. So coefficients are ... So it'd be 5, 7, 2/3. And then we have ABC. What's out front of ABC? Nothing. So what number would we put there?
1.
Yep. It's a 1. So it's like an understood 1. The number or variable holding up the exponent. Yep, that's called the base. So an example would be 6 to the 3rd power, or x squared. So the bases are 6 and x. The power above the base tells how many times the base should be multiplied. Exponent. Very good. So an example would be if we have x squared, a be 4, or 4 squared. Exponents are ... 2, 4, and 2. Terms that contain the same variable raised to the same exponent. If they have the same variable raised to the same exponent, they're like terms. So examples would be, let's say, negative 74x and 3x. Those are like terms. I'm going to put a comma. And then if I have 4x squared and 1/2 x squared. So it has to be the same variable, so x, and the same exponent, x squared. So x cubed and x squared are not the same. They're not like terms. Terms that contain different variables raised to different exponents. Exactly. So example would be negative 4x squared and 4x. Those are unlike terms. Even though they both have the same variable, they both don't have a squared or to the first power. Another one would be 4a and 4b. Those are unlike terms. So out here, we're going to put cannot add or subtract unlike terms. Only like terms can be combined when adding or subtracting. They must contain the same variable and exponent, or they cannot be combined. Go ahead and write your name on the top of this in case it falls out of your journal. You can write today's date if you'd like. It's up on the board. Okay, let's talk about combining like terms now. So simplifying expressions. The way you simplify expressions is you identify any like terms and then add or subtract those like terms. So this first is an example. What I like to do is circle or underline my like terms in the same color, which obviously you can't see the colors here. But if you could, you would know that 5x and 3x are the same. Negative 3x. And then 2y and positive y are the same. You always take the sign that's out front of it with it. So even though it says minus 3x, 2y minus 3x, we can also think of it as a negative 3x. So you just need to carry the sign with it. If you just add it, that would be wrong. So this is 5x minus 3x, giving us 2x. All we did was rearrange. Remember, that's the commutative property. If we rearrange addition or addition, it's still the same thing. So we took the sign with it. And then our y is 2y plus y, which comes out to 2x plus 3y. So now we have 6 problems that we're going to practice with. So you will combine like terms, and these are your answer choices. You will put them in the box. We don't have to cut anything out. On the digital one, you're dragging and dropping. So I'm going to give you a few minutes to do that. So I'm going to pause it. Okay, there is a mistake on here. This should be 12n plus 4. Same thing with your paper copy. I made a mistake. 12n plus 4 right there. Hopefully that's the only one. You'll see if you find any other mistakes. Okay, so let's see how you did. 8n minus 6n. 2n, so I can mark that out. 12n plus 12 minus 8. So the only thing I can combine are these. 12n plus 4. So that's that one. 6n and minus 2n would be 4n. And then plus 11. N and positive 9n. 10n. And then positive 10 minus 3. Plus 7. N and negative 5n. Negative 4n. And then 4 minus 9. Keep, change, change. 4 plus a negative 9 is negative 5. And then 7n minus 21n. Negative 14, exactly. And then positive 3. And we can use our regular graphing calculators now. Now that we're done with our first units, now you can use your calculators. All right, let's talk about what the distributive property is. So what is the distributive property? It combines.
Oh, multiplication.
Yeah, multiplication. And I'm going to put add/subtract. Okay, when do you need to use the distributive property?
When the numbers outside of the parentheses
Mhm.
with the variable.
When a term is outside a parentheses that has an expression in it. That's a lot. In it. So a number is beside the parentheses, and inside that parentheses, there's some kind of expression in there. The expression would be add, subtract, multiply. No, add or subtract. And outside is multiply. So an example would be, let's do 5 parentheses x plus 2. So we are going to multiply the 5 times the x and the 5 times the 2. I circle what's outside that's being distributed because sometimes it's a negative. You have to remember to take that negative with it. So here, pretty straightforward, 5 times x, and then 5 times a positive 2. 10. What operation do I put between them?
The plus sign.
Plus, because whenever you multiply 5 times positive 2, you get a 10. All right, so your assignment is to do the rest of this page. Distribute and write the answer out here. Okay, so go ahead and do that, and we will go over it tomorrow.